actual viewers. Right, so again, background music tonight provided by Arvinez from YouTube, RVNEZ, bringing him back over there. So, the robots. The robots. Okay, so Pi Zero had this contest. It's pretty cool. Adafruit had this contest. Pi Zeros, it's a new Raspberry Pi, it just came out. They're really hard to find because they're in very high demand. So Adafruit had a little personal stash. Actually, Lady okay, I won't. Anyways, if you go to that hackaday.io address and you go to the IQ0 project, you will find there are links to some of the videos and the diagrams as well. We'll look at the diagram in a minute. And this is one of its incarnations. So the project actually won one of the I'm just checking on the chat. Hey, yeah, man, I agree. Mr. Donnie, you should use like whatever language gets you started, man. Incidentally, I learned how to program is a crazy story because my family was really poor and I didn't have a computer at all of any sort. And really, most people didn't. They were crazy expensive still at the time, so it's a long time ago. And but the Radio Shack in my town did have a display model TRS-80. So I would skip school and go read the books that they had about how to program it. And then I would write the programs on paper at home overnight, and then I'd bring them in the next day and type them in to their TRS-80 and then test them out there. So that's how I learned how to code. In my head, actually, is what I mostly do. Yes, write the programs out on paper. And since my access to the computers was limited, obviously, I really made it a point of making sure my programs made sense before I brought them in, because I didn't have much time to play with them once I got them coded in. I don't know why those guys never kicked me out, but I'm glad they didn't. Okay, so here's another of my crazy diagrams. I might be kind of famous for crazy diagrams. But, okay, so genetic algorithms. Oh, yeah, okay, so I just remembered when I was taking the break, I remembered something I really need to do for this project, and I promised to do, was to provide a video explaining how it is that it is unprogrammed and how it runs a genetic algorithm on an ATTiny85. The ATTiny85 is, let's get the stage camera action going here. Let's see, stage 20 maybe. Yeah, no, it's weird. I don't know why those guys never kicked me out. I guess they were like, yeah, screw it. Why is this kid in the store every day? Shouldn't he be in class? But yeah, it turns out it was what I needed to know anyways. What they were teaching me in class at the time was not what I needed to know. Okay, so we're looking at at a breadboarded circuit, one of the incarnations of IQ0. You might be like, what the heck exactly am I looking at on there? How come there's only one tiny chip? Yeah, this isn't an Arduino project. This is an ATTiny85. It's an Atmel chip. Let me see if I think I have one over here. One moment. Okay, here we go. Yeah. Yeah, so there's an Atmel ATTiny85. Yes, I should be grounded or something, but I'm not. God, screens are always reversed. Yeah. It's an 8-pin DIP package type. That's redundant. DIP package circuit. It's got 8 pins on it. We might look at the pin out or something like that. They're like $1. You can get it down to 50 cents or something. It's super cheap. It's a 8 megahertz processor, 1 to 8. I think they can run up to 20 megahertz, and there's some other tricks too. that you can do. The cool part is, if you like now with the proper support, you can code them in Arduino um, using the Arduino environment, which is Coolio. So the code for this is also up on the Hackaday address. That's on GitHub, and you can get the URL on that address again. So IQ0 is the project you're looking for, and here's actually the Arduino code. We can take a look at it. Straightforward. Was I about to say it's straightforward Arduino C code? Okay. Everything about that's true except for the straightforward part. It's not straightforward code at all, actually. It's kind of slightly insane. It's clean, though. It's much cleaner than the serial bridge, so you'll have an easier time reading it if you're interested in how it works. And we are going to talk a little bit about how it works, because as I said, this is supposed to be an intro to that, or at least covering how it is that it comes up with instructions. So the ATTiny is ATTiny85's very restrained platform. Should we get the specs on it? Okay, please hold on for lag, because this is a pretty slow machine that I run for the streaming, and it's liable to lag when I do this. So 85 specs, yeah. Good enough. I probably did mean that. I really don't want to load a PDF, because that also, oh well, there's 20 megahertz, 8K. There we go. The high performance, low power Atmel 8-bit AVR RISC-based microcontroller combines 8 KB of ISP flash memory, 512 bytes of EEPROM, 512 bytes of SRAM, and 6 general purpose I/O lines. 6. I'm confused. Oh no, that's right. That's 6. Okay, never mind. 6 general purpose I/O lines. So, for instance, on your Arduino, well, this is not a good way to see it, but there's still the Arduino pinouts there, and you got like, what is it, 32, 16, 12 GPIO lines, however many it is, depending upon the model. This one has 6, so much more Spartan, so to speak. We are at Mill. Okay, there's some little thing there. So you get 6 GPIO lines, 32 general purpose working registers, 1 8-bit timer with a counter and compare modes, 1 8-bit high-speed timer counter, USI, I don't even know what that is, internal and external interrupts, I do know what those are, 4-channel 10-bit AD converter, programmable watchdog timer, and internal oscillator, 3 selectable software selectable power saving modes. What? Okay, I gotta look into that, but I didn't know about that yet. And debug wire for on-chip debugging. Hey, that's a lot, man, for like 50 cents or maybe $1. Whatever, how much, they're pretty cheap, super cheap. And it achieves a throughput of 20 machine instructions per second MIPS at 20 megahertz and operates between 2.7 and 5.5 volts. That's right, you could power this little bugger off of a couple of AA's. Isn't that cool? So a couple AA's and you've got your little microcontroller processor project for $1. And if you blow it up, it's like hardly no big deal because it's $1. So you get a bunch of them. Oh, and here's the other specs. You'll find this information at atmel.com/devices/ATTiny85.ASP. Are you kidding? ASP, really, guys? ASP? Okay. Anyways, yeah, enough mocking the Microsoft infrastructure stuff. So IQ0, the source code. The source code. Not IQ0, the t-shirt. Not IQ0, the movie. All right, which it will be when it takes over the world, probably. So IQ0, what makes this different than like a regular robot? I really need to show that video is the thing. Okay. All right, so let's watch it for a minute. This is IQ0 starting off. Wait a minute, what am I doing? This is backwards. Okay, I'm gonna have to edit this now. This is backwards. It doesn't make any sense because if you're watching a robot like this, you're like, man, this is the stupidest robot. which is exactly what I called the project. I called it stupid, stupid evolved robots. So they are stupid. The thing has no idea what it's doing. Yeah, that lag is horrendous. Okay, I'm gonna stop it. Okay, we can't play videos while we're streaming. This much has been determined. And itself in my head. Okay, so, well, you know what? Maybe I could just start with this. Actually, that's true. I should start with the IQ0 article on hackaday.io because, after all, it worked for the contest. So that must, I mean, at least it was good enough for that. Well, okay. There we go. What's up with this project? Exploring the intersection of genetic algorithms, robotics, and procedural generation, IQ0 is a sort of robotic corollary of general AI. Instead of explicit instructions, productive behavior emerges from random noise. Random noise is in scare quotes because if you're, if you're a geek, you're a programmer, you understand that that doesn't really exist. But so productive behavior emerges from random noise by modeling random mutation and natural selection, the processes of evolution. This is genetic algorithms in a nutshell. Um, Now, it's running on an ATTiny85, so where do you get all of this genetic source material? Well, I'm leaning on some procedural generation techniques to generate DNA on demand at runtime. That sounds like one hell of a crazy project. Um, so, and it is, and it's pretty cool. And the Adafruit people liked it, and the Hackaday people liked it, and they awarded it one of their 10 Pi Zeros. So that was pretty cool. And you get the information about it on here, as well as this is actually a much more complete project in terms of the information. It has all of the code you need and instructions for building one and all that other kind of stuff. So, um, hmm, well, I was thinking about a couple of different ways of describing this as a project. Um, One way I was thinking, and I should have had a visual illustration for this. Maybe I can find a picture. Actually, pretty much I do anything on this machine while I'm streaming will really kind of kill it. Okay. How about this? Here's an idea. Good enough. Yeah, this will do. This will do just fine. Actually, this picture right here. Shut up, Google. I don't want your help. I just want this thing. The thing I came here for. Okay. Cool. All right. Let's say, take a look back at this right here, right? This is a circuit. This is the circuit actually being used for this IQ0 robot. And one of them, it's a very simplistic circuit. There's nothing here but an LED and two servos and a switch and their connections to their microcontroller, which is the ATTiny85 and my cat's toy ball. That's the test environment for that robot. So that's a circuit, right? Just so that we're setting some sort of a baseline. Sorry about my hair. New haircut and it's crazy. So that's a circuit. It's highly ordered, right? What we would call in the natural world highly ordered, as opposed to disordered. Now, this picture on the left here, which I got when I just looked for, what did I look for? Like pile of components or something like that, mixed electronics component. The pile on the left is what we would call highly disordered, right? It's not a circuit, is it? Or is it? That's the question. Is it a circuit? I'm not asking whether it's a good circuit. I'm not asking whether it's an efficient circuit. I'm not even asking what kind of circuit it is. I'm asking, is it a circuit? And I think technically it is a circuit, right? A circuit doesn't have to necessarily have been designed, right, or engineered to be a circuit if a binary converter or something, if all the pieces of a voltage converter fell into the right places such that it was a functioning voltage converter, would you not still call it a circuit. It is a circuit and it does a job. It's a voltage converter. You might be thinking, where the heck is this going? What is this crazy person? But before you think I'm a crazy person, remember that I've got all these other projects that we're working on. And so I may be a crazy person, but there's something to it. So think about that for a minute. Is a pile of first of all, two questions. Is a pile of mixed electronic components, is it a circuit if it does something? And the second question, follow-up question is it a circuit if it doesn't do anything? Right? So think about that for a minute and go to that URL and check out the project IQ0 Evolving Unprogrammed Robots. And you might hackaday.io/diemastermonkey. Special shout out to Phoenix Plays and everybody else for showing up, and this flying person who had fists, and Mr. Donnie who's learning code, and that's cool, dude. You totally should. And I regret that there is no Radio Shack for you to go and hack their display model Raspberry Pis. So we need to, but there's hacker spaces now, so find a hacker space. And I'm coming back. So I get 5 to 10 minutes, and you get to think about, is that a circuit on the left? Is it a circuit? Thanks for tuning in. And we're back. Okay, thanks for letting me take that break, viewers. If there's anyone out there, I can't see at the moment because the device I use to track the Twitch chat is out of power, but I'll have that back in a little while. Okay, so the question was in regard to the IQ0 project. Quick recap, you can get information about it at the URL hackaday.io/diemastermonkey. It's called Evolving Unprogrammed Robots. And that applies to all of that, evolving and unprogrammed. Unprogrammed. What do we mean by unprogrammed? Okay, I mean unprogrammed in the same sense that this is uncircuited. So the theoretical question is this pile of random components, is it a circuit? Whether or not it's functional is another question, a separate and distinct question. But if it can be considered a form of circuit, if you do consider it a form of circuit, then you're halfway to getting where I'm going with these unprogrammed robots. They are unprogrammed in the same sense that this is an undesigned circuit. Now, it's likely that if you take two leads from a 9-volt battery, or what the hell, why not a car battery? Yeah, take two leads from a car battery and connect one of them to one of these pins of any of these components at random, and connect another one to one of these other pins that are poking out of this pile. Chances are highly likely you will find no connectivity at all. No conductivity, i.e. no circuit running between those two components. But I do believe that if you connect enough of them, you may eventually find somewhere where there are some consistent connection between them, maybe the leads, maybe the cases, maybe some random piece of wire that happens to be bridging two of them. If you check enough of these connections, you are going to find, certainly if it's a big enough pile, some places where there is a conductive path all the way through. And you would get an unpleasant surprise, I assume, if you were using a car battery. I'm kidding. Don't do this with a car battery. In fact, don't do this experiment at all. I've actually wanted to do this experiment, and I never have. But I'm still kind of eager to do it. I haven't done it. I should say I haven't done this experiment in circuits, but I have done this experiment in code. And that's what IQ0 is. IQ0 is programmed, or rather unprogrammed, in the same way, again, that this is not a circuit, or in the same way that this is circuited. If that's actually it's designed would be the real engineered. I don't like that word, but so you get the idea. Now, I know I'm finally back in the chat, by the way, but it means I won't see stuff that you guys have already said. I apologize. So if I miss something you already said, please feel free to reiterate it. That's okay. So you're probably thinking, this is crazy talk. This is, first of all, again, let me remind you that this project is in fact already in production. You can go download the code yourself and build one of your own IQ Zero Unprogrammed Robots and play around with this concept. So here's the diagram. Wait, sorry. Never mind. Pay no attention to that diagram. Too soon for the diagram. I want to get back to the pile of random crap. Okay, pile of random crap. Can a pile of random crap be functional? Okay, so certainly it can be a circuit. We know that, especially if it is complex enough, right? Complex is. Man, I like discussing this stuff, but I'm not sure if I'm hitting the right points. Because I mean, now we're talking about determinism and chaos and stuff like that. So, okay, well, so you can come up with some sort of a functional circuit with this random combination of components like that. As a corollary, how would we consider the same sort of thing like programmatically? Okay, so over here, I'm logged into my Linux box, which is actually where I do most of my development. You guys don't see that stuff because I need to do some reconfiguration in the studio here. But when I do, hey, hello, Fame Beast, and other people, if you've joined, I apologize. I'm a very bad stream host, but I'm still here, so there must be a reason. You'll see why. So on my Linux box, oh, you guys can't see that window. Hold on. On my Linux box, where I do most of my development, unfortunately, you guys can't see it yet, but I'm working on changing the studio layout so that I'll be able to do more shows that include that sort of thing. Let's hope this wraps around correctly. Okay. You're not going to be able to see that very well. But here's a one-line of Perl command to produce a random string of numbers between 0 and 65536. Okay? It's really pretty straightforward. It just says, for as long as forever, just keep printing out random numbers between 0 and 65536. You know what? I think I'm going to change this while we're talking. Wait, I can't do that while I'm talking. Hold on. Well, I wanted to do it so that it would just do 10 of them or something so that I could do this demonstration. We'll have to make a script for it. All right, so there's a bunch of random numbers between 0 and 65536, right? You know what? Just for the sake of argument, I'm going to change it to random numbers between 0 and 4. Okay, 0 and 4. Here's a bunch of random numbers between 0 and 4 coming out of my Unix box. Coming out of Perl, actually, right? So the first one is a 2, and then there's a 1, and then there's a 3, and a 3, and a 2, and a 0, and a 0, right? So that looks like a random string of numbers. Could it be interpreted as code, right? Could a random string of numbers be code? Could random data be code in the same sense that this is a circuit? Right? So how would we go about doing that? So I'll give you an example. Let me see what you guys are seeing so that I can make sure to do this. Let me get back to this diagram so you guys have something more interesting on the screen there. Okay, that's what we're talking about. Evolving unprogrammed robots, and here's one of them. But I'm going to take that off the screen for a moment while we do a little exercise with this. We're going to pretend this is an unprogrammed robot, right? Unprogrammed robot. In fact, Mark Rubio. In fact, I'm going to make this a little more appropriate for the audience. And we're going to pull out, yeah, okay, so there's my geek cred right there. Anyways, so our program is going to be let's make it easy. I'm going to use a 6-sided die. What the hell. I'll use a 12-sided die. D12 here. I'm pretty sure that's a D12. Am I really still that geeky? Oh my god. I spotted a D12 like on site. I didn't even have to count it. That's old school. All right. Anyways, so here we got our D12 here, right? Let's say this is our random noise. in the same sense that that circuit was random noise, right? Circuit, again, I'm going to refer to this as a circuit from now on, right? We already determined it could be a circuit under the right circumstances. Maybe it's all about context, right? Whether something is a thing or not kind of depends on its context. I'll tell you one of the things that got me thinking about this. I'll give you two things that got me started on thinking about this like 10 years ago. I've been playing with these ideas. One of the things that got me started on this was I'm really into like nuclear power and stuff. I just think it's cool, and nuclear fission is cool, and all of that stuff is cool. And so I'm into reading about that. And did you know that there have been plenty of natural nuclear reactors? Yes, it's true. Happens a lot, actually. It has happened plenty of times over the course of Earth's history. Um, and it can happen simply if you get the right, and I apologize for the lag, you guys. I got a really slow machine, but it'll be temporary. Great, this is a fantastic example. This is the kind of famous example. It's, I believe, in France, in Gabon. That must be French, right? So, in Gabon, there were some sandstone concentrations, uranium ore concentrations, and granite concentrations that just happened to be in the right arrangement and the right configuration. Hey, Phoenix Blaze, just saying hi to everyone. So, in the right configuration to reach criticality and to result in a self-sustaining nuclear fission, naturally, just randomly. The components just fell into the right places, the right arrangements, and the right amounts, and it wasn't completely stable. It would start up and then produce fission for a few thousand years, and then kind of fall out of alignment and pass criticality. So there's a very fine range. It has to be sort of like tuned so that you get this self-sustaining reaction. If there's too much reflection, then or too little, then you don't get the reaction. So, and these have happened. This is a natural nuclear fission reactor. So that is a functional device, a functionally unengineered device, in the same sense that this is a circuit, an unengineered circuit, and in the same sense that the IQ0 is an unprogrammed robot. So this is one of the ideas. When I heard about these nuclear fission reactors, I was like, man, that's freaking cool. It's like something that is so complex that we consider it one of our most, one of our most fundamental advances, and it can happen by accident. So, I mean, what else can happen by accident? How advanced can an accident be? Okay, so back to this. Say, for instance, we had an unprogrammed robot and random stream of data. Here we go, random stream of data, right? Let's say that any even number, what we can do to turn noise into something functional is to add context. This is the conclusion I've come to. So let's say every even number means the robot will turn left, and every odd number means that it will turn right, and 12 or 1 means that it will go forward, right? So we're going to make a noise program for it. So odd number, it's going to turn right, right? Even number, it's going to turn left. I got a 12. I should be reading you guys the number. 12, that's going to turn left, even number. Oh wait, no, 12, it's supposed to go forward, huh? Okay, see, there we go. Now it goes forward, right? 7, odd number, turns right. 3, odd number, turns right. 12 goes forward. Look, we've got a functional sentry program here. It's a functional sentry. It does this, right? But you say, well, it wouldn't be functional by at least some minimal context. Here's the problem with the program. It's not repeatable, right? Because every time I run this, it's a different set of results. So we would say that the program changes every time, right? That's not really a program in any real sense, not a usable program, right? Okay, wrong. And we're on my Linux box now because I don't have Perl installed, and Perl is my quick prototyping language of choice. So for this kinds of purposes, I'm just going to make a quick script here. It's called random, and we're going to edit it in Vi. So it's going to be ugly. Okay. Okay, so in this here Perl script, yeesh, man, that is ugly, the coloring. Anyways, in this Perl script, I will tell it to generate a random number, right? In fact, I'm going to tell it here. And all we need to know is, man, I almost forgot my Perl there for a minute. All you need to know is this is going to count from 1 to 10. It's going to produce 10 random numbers, right? And this will look very similar to the same syntax you would find in other languages. It's going to look like, I'm just going to, you know what, I'm just going to spit the number out, actually, just so that in case we want to do something useful with it. And that's it. Oh, right, why am I doing this? X, so X is going to be the random number. And here's how we get a random number in Perl. We say X equals, oh shit, I hope I'm doing this right. I think it's that. Yes, we're going to find out in a second here. It's probably that. Okay, let's find out. What was I using before? Sorry, it's int rand, and then you put the number in there. I should probably slow down. So this will give us a random number between 1 and 12, right? Just like the dice. Okay, here's the syntax. Let me see if I can get the font a little bigger for you guys. Give people a little time to look at that while I try to increase this font here. Background music again tonight provided by R. Vinez. You'll find him on YouTube, and I'll provide links in the replay stuff. And I haven't asked him for permission to use this yet, but he's a cool cat, and I think he'll be okay. I'll ask him. So I've just been listening to his stuff recently. So okay, that probably works. Let's see. Okay, so when we run it, it spits out however many I said. 10 random numbers between 1 and 12, is it? Let's check that syntax again. Blah, 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 blah. Yeah, X equals thing out of 12. Okay, so sorry about the syntax coloring, man, it's ugly. But you'll see that this produces a different sequence every time. So when we run it, it gives us 10 numbers. It gives us 10, 4, 0, 10, 0, 4, 1, 1, 3, 3. So according to our instructions, right, this program would go like this. Remember, even numbers are going to go left, odd numbers are going to go right, and 12 goes straight ahead. In fact, let's say that actually this is only going to go to 11. Let's say that 11 or 0 goes straight ahead. Okay, so we're going to run the program now. Even number, turn left. Even number, turn left. 0, go straight. Hope I don't run off screen. Even number, turn left. 0, go straight. Even number, turn left. Odd number, turn right. Odd number, turn right. Odd number, turn right. Even number, turn left. Okay, not a very useful program, but a program, right? Okay, so let's run it again. Let's see what we get. 0, 6, 0, 5, 10, 4, 7, 7. This is just like the dice. It's random every time, right? 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 Actually going to find out it's not quite random. And now we're about to leave science and enter philosophy. The problem with digital logic is, well, actually not the problem. It is its strength. It is completely deterministic. That is to say, if you put the same inputs into a computer, you will get the same output every single time. You say, no way, that's not true because I play like blackjack and I get different hands when I play blackjack or solitaire or whatever. And it's not the same every single time. Actually, it is the same every single time. Um, what's really happening is they have a lot of different lists of random numbers, and they are choosing to show you a different list each time so that it feels like it's different, but actually, under the same conditions, it's the same list each time. That sounds pretty abstract, so let me show you exactly what I mean. Um, in 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 what? Well, okay, jeez, maybe this is out of my depth. We're getting into PRNGs and stuff. I'm not sure I'm capable of really covering that. Um, I don't want to get into the math of how a computer generates a number that it's going to tell you is random. Um, for that, you can look into a thing called PRNG, pseudo-random number generator, which is what computers use. But in Perl is a good example. You there, you know, probably the best way to do this is just to give you is just to show you. Okay, so I'm going to use this command called srand. All you need to know right now is that this puts a seed. We're going to call it seed. The PRNG. It puts a seed in the pseudo random number generator. Pseudo, that means like part way, like not really all the way, right? Like, why is it called a pseudo random number generator? Is it a real random number generator or a pseudo? No, it is a pseudo random number generator. It can't really generate random numbers because it's being a computer. It's completely deterministic, right? You know what? I just realized I put that in the wrong spot. Okay, hold on. All right, there we go. We're using 5, by the way. Okay, so now when we run random example, I will run random example again. We get a series of numbers: 5, 10, 8, 11, 5, 7, 1, 1, or 1, 5, 3, right? Let's imagine that looks like this, right? I'm not really going to run it, but you get the idea by now. Now, if we run it again, we get 5, 10, 8, 11, 5, 7, 1, 5, 3. Wait, what? What's up with that? That's the same list. Why is that happening? Yo, Phoenix Blaze, thanks for dropping in, man. Dig you, and also Fame Beast. Nice to meet you. Hey, I remember you, dude. And okay, so wait, what? Why are we getting the same list of numbers again? That's like a glitch, right? We'll run it again. Wait, no, we get the same list of numbers. What's up with that? Why does that happen? Well, that's because, as I was saying, like computers completely deterministic, right? What it tells us what is presented as a random number is not really random. It's actually a number selected from a long sequence of numbers that comes out of a formula. The formula is convoluted, and it may depend on the platform how convoluted it is. More convoluted seems more random and is harder to predict, or whatever other factors. But it's still not random. It is still dependent upon the inputs to the formula, right? Popular inputs to these formulas might include something like the number of seconds since December 1st, 2000, or January 1st, 1970, or something like that, or the temperature of the room, or something like that. Is a really good one. That sort of thing. The audio levels received by the microphone combined with the temperature of the room in some way, so that they're are unique every time. Still, that means that even using that model, the exact same audio levels with the exact same temperature from the room will still produce the exact same results in the exact same order. That's right. I know. It's amazing. This is really the basis. This is like half of the basis for procedural generation. So like Minecraft, this is how Minecraft works, right? Is you could have like this huge list, right? So again, this list, our list, which says, odd numbers we go left, even numbers we go right. Wait, whatever it was. And then like 0 or 11 we go straight. So down we get to, okay, odd numbers left, even numbers right, right? Okay, left, right, right, forward, left, 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 left. That's that program, right? Now, if we run this program again with that same seed, We get the exact same sequence. Do you get it? This is because of this number, because of the seed we're providing. If I change this number, we get a different one, right? We'll get a different sequence. So I'm going to repeat this exercise again, but this time the seed is 14, not 13. It's not even, see, the output is not even remotely related. First time with the seed of 13, we get 5, 10, 8, 11, 5, 7, blah, blah, blah. Second time, now that we're running with a seed of 14, we get 4, 7, 5, 4, 4, 9, 7. It's no relationship, even though the number is only one tiny number different, right? Because the formula works in such a way that if you just change the number a little, the formula is the output's dramatically different. This is what you need for something to seem random, right? It's trying to seem random. But again, if we run it again with the same seed, we get the exact same output. 4, 7, 5, 4, 4, 9, 7, 6. So I'm going to do this just for the heck of it, because I think this will be funny to see. Instead of printing each number on a new line, I'm going to print them right next to each other. And instead of printing 100 of them, I'm going to print 240 of them. This would be like 100 columns or 100 rows at, actually, maybe we'll do 120. So that's 50 rows at 12 columns or 24 columns. Okay, so when I run this now, and we're using the seed of 13 or 14 now, right? Oops, sorry. I running it instead of actually running it. Okay, there we go. It's a big string of numbers, right? It's the same big string of numbers every single time. It doesn't matter how long this string of numbers is. Get it? It could be huge. It could be gigantic, like as big as, oh, I don't know, an entire Minecraft world maybe. And it will be exactly the same every single time, no matter how complex it appears. So this might be an extremely complex program when we add enough context to interpret it as a program. But to recall this program, even though it's a super complicated program, we only need one number, 14. This can be an extremely complicated program, really convoluted with millions of instructions, maybe 65,536 instructions, which how many the IQ Zero currently has, in theory, 65,536 individual instructions for its DNA. And those are all consistent and reliable and recallable at any time using just one number, which is good because it's all running on an ATTiny85. And I don't have room for a whole lot of numbers. But I need a mechanism to recall a really large complex data set using just a couple of key elements. And that's how IQ Zero turns so-called random noise into commands with its own code in there. All the rest of this is covered on the project site at, so this is IQ Zero's brain. It looks like this, basically. The second half is how do you take something that's mostly noise and mostly garbage and then, you know, like just throw away the parts that don't work. So this will I think I'm going to cover this in the next show. Pretty much tapped out for tonight, I think. But so that is an important part. Obviously, it's an important part of the process. You can't just, we don't have time like the Gabon nuclear fission reactor, like the natural nuclear fission reactor in Gabon. We don't have billions of years to wait for the right pieces to fall into all the right parts, right? So there is another part of the process, not just this procedural generation part. The other part of the process is evolution. So there's two ways to find out about that. One is to go read an excellent book about evolution, such as Richard Dawkins' Greatest Show on Earth, or any really good high school or college biology textbook on evolution, as long as it didn't come from Texas. So, and you can tune in for the next show, wherein I'll cover how the evolutionary model is applied to IQ Zero and how that manages to turn a pile of random gunk into a usable robot brain that actually gets work done. So thank you again, everybody, for tuning in, and special shout out to RVNez, YouTube user RVNez, who I will link to in the replay video venues, for providing tonight's background music. And thank you all for tuning in, and new subs. Love you guys, and my lurkers as always. Lurkers power the channel. And also another shout out to Adafruit and Hackaday.io. Thanks for the Pi Zero. Looking forward to putting IQ Zero onto it and seeing what a crazy, insane, unprogrammed robot can do with a 1 gigahertz processor. So thank you everybody for tuning in, and see you at the next show. Stay true, stay low.